In this video, I'm going to be showing you when to use chains rule and how to apply chains rule. The first thing we need to know is that if you want to use chains rule, then your function must be of this nature. You must have a composite function. That is y equals something of the nature f of g of x. So if you notice this very well, you would have two functions. Of course, you can even have more than two functions, but you would have two functions at the basic level where these two functions can actually act on their own without necessarily having to depend on each other. What am I trying to say? For example, if you have these two functions, you can have f of x equals x squared. Now, this is a function that is a quadratic function on its own. And you can have another function, say g of x equals 3x plus 5. As we can see, this is a linear function. But if I combine these two functions together and write this as y equals 3x plus 5 all raised to power 2. As we can see now, we can see that the g of x, which is 3x plus 5, the linear function, is now embedded inside the quadratic function. And in place of x, we have 3x plus 5. So originally, what we're supposed to have is a function that is standing on its own, like y equals f of x. So basically, when you have functions such that in any position that x is supposed to be, you have an entire function on its own, a function that can behave and that can stand alone on itself. That is when you apply chains rule. And this is a very simple one of it. In the course of this video, I'm going to be giving you some other advanced problems, but let's start with this particular one first. How do we go about functions like this? It is just as simple as you splitting them. So if you're given y equals 3x plus 5 raised to power 2, and you are asked to find derivative of y with respect to x, that is, we are looking for dy dx. Now, to find dy dx in this situation, what we need to do here is to say, now, you choose any favorite letter of your choice, anyone that you feel like. So u is widely used. Let u equals, the first thing you need to do is to identify that inner function. You must be able to identify the inner function. You must be able to split each of these functions separately on their own so that they can stand as individual functions. So if we split this, you realize that 3x plus 5 is the one inside. You can say let u equals 3x plus 5. And the next thing to do here is to find the derivative of u with respect to x. And what's that going to be? If you differentiate u with respect to x, this is 3x to the power of 1. 1 times 3 is 3. Then 1 minus 1 is 0. So we are left with 3 here. And this is a constant. When you differentiate a constant, you have a 0. And if that is settled, now you need to rewrite this function now, such that this function is going to be rewritten and we're going to have y is defined as a new function. Instead of 3x plus 5, 3x plus 5 is now u. So we have u to the second. And the next thing you do again, for every of these steps, you need to perform a derivative. You would find the derivative of y. Now, y is now defined as a function of u. So you are differentiating y with respect to u. And what's that going to be? That's going to be 2 multiplied by 1 is the coefficient here. So you have 2u, then 2 minus 1, that's 1. So you have the derivative of this. This is all the derivative that we'll be needing. Now the next step to do here is to use the chain rule itself. What does the chain rule say? It says that if y is a function of g of x such that u equals g of x, then the derivative of y with respect to x can be taken as derivative of y with respect to u multiplied by derivative of u with respect to x. So which is what we're going to be applying here. We already have derivative of u with respect to x and we have derivative of y with respect to u. And according to our problem in this place, we have what is derivative of y with respect to u? That is this, which is 2u. So we have 2u multiplied by, and what is derivative of u with respect to x? That is 3. 2u multiplied by 3. This is going to be equals to 6u. And final thing that we need to do is to substitute our u back, which is going to be 6 multiplied by 3x plus 5. And if you like, you can expand this, and if you like, you can leave it this way. It's not really necessary what you do after here. It's just, this is just the final answer. And if you want to expand this, 6 times 3 is 18x plus 6 times 5 is 30. And that is the derivative of this. Now, let's do one more example that involves trigonometry function, and that is a little bit complex than this one that we just did here now. So what if I have the equation, say, y equals sine of 1 divided by x. Now, if I have something of this nature, now you would realize that we have two functions. First, we can have f of x as sine of x. And we can see that g of x in this place is going to be equal 1 over x. So it's very basic. Sine is a function which on the natural ground, it should act on x. And now what is inside is not ordinary x, it's 1 divided by x. Just extract that out and replace this with x. So these are the two functions we'll be dealing with. So what do? Say let u equals 1 over x. Now if u is 1 over x, this can be written as x to the negative 1. So if you write that, that implies that derivative of u with respect to x is now going to be negative 1 multiplied by x, negative 1 minus 1, which eventually will give us negative x raised to the power negative 2. And you can write this in fraction form as negative 1 divided by x squared. So the next thing we're going to be needing to do here is to rewrite this function out. So y is now going to be equal to sine of u is now 1 over x. So this will be sine of u. Then we have derivative of y with respect to u is then going to be equal to cos u. And the final thing to use here is to apply the chains rule. So to apply the chains rule, we then have dy dx is then the product of derivative of y with respect to u multiplied by derivative of u with respect to x, which is cosine of u multiplied by the derivative of u with respect to x, which is negative 1 divided by x squared. If you multiply this very well, you have negative cosine of u divided by x squared. And final thing to do is to substitute our value, which is going to be negative cosine of what's u? U initially was given to be 1 over x. So 1 divided by x, everything divided by x squared. And this is how you apply chains rule. Of course, there are more difficult problems than this, and it's just the same approach. If you have a particular problem in your assignment that you would like me to address, whether on chains rule or any rule of differentiation or in calculus general, drop it in the comment section below. Don't forget to subscribe to my channel as well so that you can see future videos, and like and comment as well. I'll see you in the next one.